Okay, so let's look at example 5 here, which is going to make an executable that we link against a library from example 3, a static library. So if we go into example 5, then here we're going to build an executable. We'll install that in the run directory, and we have a source directory, and that source directory contains a CMake list and a simple executable, or a simple driver routine main. So let's look at the top level, and here we have the minimum required. Give it a project name, some verbosity and C++ standards, and then we're adding the subdirectory for that source. So if we go into the source, then let's just look at use hello. It's like it was in examples 1 and 2, pound include hello.h, and then we create the object and call the function. And then if we look at the CMake file, it's shorter for this executable, and we have add an executable target that we're calling use hello.x, and then we have target sources. It's possible to chain these up, so you could add the sources in one line, but here I'm separating it. So target sources use hello.x, private use hello.cc. And then, so anyway, the private keyword, again, we've talked about that before, but is used to indicate that use hello.executable depends on use hello, but anything that uses this executable later on or links against it, etc., won't use that. So for an executable, that's sort of obvious. And then we're going to create, then we need to link this executable itself. This is the source code of the executable that we're going to create, but it also depends on that hello library, so we need to link against the hello library. So for that we'll use find package and then give it the name of the library hello. And in order to find that package, we have to tell CMake where to look. So it'll look in standard locations for us, but we put it in a pretty non-standard location up here in this user folder, user example 3. So the thing to do there is to do export. Well, I'll just show you what I have in the CMake. So I created this variable CMake prefix path, which CMake will recognize. This is an environment variable, and in this example we have put the path, in this case the location, to example 3, and also example 4, and also example 7. So you'll want to put that in there so that CMake can find the library. You could also put hints here and tell it where to look. So in this case, users deal for downloads, and actually anyway, the path to the location would go right there. So I won't do all of that. But in our case, I actually let's go ahead and get rid of the locations that are in those in the CMake, and we have those codes CMake examples. We'll just delete that folder, and then because we're working in downloads right now, and we'll just export CMake prefix path is slash users me downloads CMake examples user, and then we'll do example 3 like so. And then if we look at that again, we can see that we've put that path in. Perfect. Okay, almost done. So anyway, you just need to know where to look. And then it's as simple as linking against that library. So our target is going to depend on that library, And that library we gave when we built it and installed it with that config command in the previous video, we gave it a namespace of hello, so this allows it to resolve it against hello, hello is the way that we would access that. And you can look up to see why exactly we use this : namespace notation. It has to do with resolving the correct object and making sure that it's a target that we found, as opposed to interpreting it as like a regular library without like the find package command here. So once we have it found and linked against, we can then install it. And so we're installing the target use hello.x in the location our project source directory /run. So right now we're in source. Let's go up one to our project source directory /run here. And then let's make the directory build cd build CMake make install. And we come up here to the run directory, and there it is. Use hello.x. Hi there. Perfect. So it worked great. So let's go ahead and do this with the static, or with the shared library now. So that's example 6. Okay, so it looks pretty similar. Same sort of stuff as before, and let's go to our source directory, and the use hello is the same. And then we have the CMake list.txt. So here we have this special command. Because we're doing a shared library, we need to use rpath linking, and this is going to allow the executable to locate the executable will have the location of the shared library inside of the executable. So that's what this command here does. Set CMake install rpath use link path true. That's a mouthful. So we're asking it to use that. And then we're adding our executable with its source file. And then we're doing the same thing as before, find the package. In this case, it's hello_shared that we want to link against. And we use the namespaces. So it's basically the same thing as we had with the static library, except that we want to use this rpath linking. And then when we do the targets here, install, we're going to tell it to run it in the same sort of location, up a directory in run. So let's go ahead and try that out. So if we come up here, mkdir build, cd build, CMake, ... Oh, and it can't find it because our environment didn't have it in there. Couldn't find the package. So let's do that. Export. And we'll just go, in this case, we'll put in the CMake prefix path, and then add the new one. So now if we look at that, we can see we've got example 3 and example 4. Start fresh, CMake ... make install. And we can come up to our run directory, use hello.x, and it works. Perfect. Now let's see what happens if we go into the source file and we remove this set install path, the rpath, and go up to that again. Make install. And if we go up and try to run it, we get this error that says that our executable is looking for a symbol that it can't find, and we have these kinds of cryptic errors. There's a tool to investigate that on Mac. If you do otool-L and then the use hello executable, you can see these commands. It's looking for lc load dynamic library, this @rpath, so it's using a relative path, /lib hello shared.dylib, but it doesn't know how to resolve this at rpath. So there needs to be a command in here, lc_rpath, that tells it where to look for this, and it's not there. So let's go back up and fix that. CMake, turn that back on, and if we come up here to build, clean it up, make install, run. Now use hello works again, and then if we look at it with that otool -l use hello.x, we can see that now there's a LCR path that allows this at rpath to be resolved, and it searches this location for our library. So that's what that command does. It puts that in there. Interestingly, the build that we made doesn't have that problem. If we go into our source and type use hello.x, it finds it. Well, this is the one that worked anyway, but it would find it here but not later, because when it installs, it strips that information out. And there's some details in there that are described with some links in the README folder. Okay, so let's stop there, and then in the next video we'll talk about another examples of some usage.